We want to solve the given radical equations. In general, if an equation contains one radical, we want to isolate the radical on one side of the equation and then raise both sides of the equation to the power of the index. This will undo the radical, and then we want to solve the resulting equation and check our solution or solutions. Looking at our first example, we have the cube root of the quantity 2x minus 1 equals 3. Notice how the first step has already been done for us. The radical is isolated on the left side of the equation. And since we have a cube root, we can undo the radical by cubing both sides of the equation. If we cube the cube root of 2x minus 1, this will simplify to the radicand of 2x minus 1. And on the right side, 3 cubed is equal to 3 times 3 times 3, or 27. And now we'll solve this equation for x. So we'll add 1 to both sides of the equation. So we have 2x equals 28. Divide both sides by 2. We have x equals 14. And now to check this, we'll substitute 14 for x into the original equation. So we'll have the cube root of 2 times 14, that would be 28 minus 1, that's going to be 27, equals 3. And since 27 is a perfect cube, since 27 is equal to 3 times 3 times 3, this equation is true, and therefore our solution is x equals 14. Let's take a look at our second example on the next slide. We have the fourth root of the quantity x squared minus 6x equals 2. Again, notice how the radical is isolated on the left side of the equation. So now we're going to raise both sides of the equation to the power of the index. And since we have a fourth root, we're going to raise both sides of the equation to the power of 4. So on the left side, this simplifies perfectly to the radicand of x squared minus 6x. And on the right side, 2 to the fourth would be 2 times 2 times 2 times 2, which is equal to 16. Here we have a quadratic equation to solve, so we'll set it equal to 0 and solve by factoring. So we'll subtract 16 on both sides of the equation. So we have a 0 on the right side. Left side we have x squared minus 6x minus 16. So if this does factor, it'll factor into two binomial factors. The first terms must come from the factors of x squared, which would be x and x. And now we want the factors of negative 16 that add to negative 8. And since negative 8 times 2 is equal to negative 16, and negative 8 plus 2 is equal to negative 6, one of the factors will be x minus 8, and one factor will be x plus 2. So this product is equal to 0 when x minus 8 is equal to 0, or x equals 8, or when x plus 2 equals 0, or when x equals negative 2. And I will perform substitution into the original equation to make sure that these solutions actually work. So when x is equal to 8, we would have the fourth root of 8 squared, that's 64, minus 6 times 8, that's 48. Well, 64 minus 48 is 16, so we have the fourth root of 16 equals 2. And since 16 is equal to 2 to the fourth, this is true, and therefore x equals 8 is a solution, and now we'll check x equals negative 2. And when x equals negative 2, we'd have the fourth root of negative 2 squared, that's 4, minus 6 times negative 2, which would be minus negative 12 or plus 12, equals 2. And notice how we have the fourth root of 16 again, equals 2, which we know is true from above, and therefore this equation has two solutions. X equals 8 and x equals negative 2. Okay, I hope you found this helpful.